Welcome back. In this video, we're going to go through an exercise basically to show you a way that you can draw a sample from a larger population and some of the additional insights that one should keep in mind when, when one is taking a sample. So what I've done is I've set up a series of random values in column B based on a mean of 75,000 and a standard deviation of 19,000. You can see that this list goes up to 1,000. And that isn't necessarily a very large population, but I just wanted to use one that's fairly simplistic to illustrate the concept and key points of sampling. It could be 1,000, it could be 1,000,000, it could be 10 million or larger. So one of the keys to drawing any sample from a population is to start with a population frame, which we have here, which is a list of incomes for 1,000 people or individuals or households. Next is to draw a random sample. And I'm going to do that with the rand function. Rand function is handy, but not something that I would expect you to use, although it's good to know about it. So in each of the cells from C5 all the way down to the last 1,000th observation, I'm going to insert a rand function. And I need to reformat that because it thinks it wants to be in dollars. So I'll just do it as a number with 4 decimals, and it looks something like that. Perhaps I should right justify that. Now, I'm going to copy that. And how you copy it, you can drag copy. It takes a moment or two. And there I am, all the way at the bottom. Now I've signed a random number for each of the 1,000 observations. Let me just save this as a completed file. One of the things that trying to do is give you a, particularly in this file, a start and a finished file so that you can review them. So now I've got 1,000 random numbers assigned. And if you do certain things, you may see that. So here's my random. The next thing I'm going to do is sort that. So I do data sort. And notice that I've left a space in column D because the sort range is only these values in A, B, C, starting with A5 down to C 1004. Because this is a continuous variable, all I have to do is sort by rand. It doesn't even matter if I sort largest to smallest or smallest to largest. And now you see that in my observations, all the observation numbers are random. So what I can do here is, let's just say, grab 10 or so and copy and paste them over here. Notice when I did that, the random numbers changed. Now I could do another sort. And it sorts them again. And I could grab another 10 and copy and paste them over. Now, the other way I could do it is if I wanted multiple samples, I could grab B15 to B24 and paste that in. I could grab B25 to B34, paste that in. And I can continue this, B35 to 44, paste that in. And so now I've got 5 samples. Maybe I'll do another random sort. All I'll do is just click sort. It's already set up. Oh, notice it has, my data has headers. which can be a little tricky to use sometimes, but it's nice if you have column totals to identify which column you're sorting by. So perhaps in the next 5 samples, I will grab 30. You know, it might be easier to just keep sorting. Oops. Because with 30, I'm going to have to be sliding way down into the file. So this actually little exercise, so you're trying to sort here. I need to keep clicking back over to my sort range over here, sorting a third time, grabbing to row 34, copy and paste. And you'll find sometimes that this exercise, say things like this can be efficient and you get pretty good at it. So here's my 4th sample. Went a little too far on that one. And one more time. See, I was so excited to explain what I was doing, I forgot to do what I told you to do. And here we go for 34. So now I can look at this from a sample size point of view and a sample mean point of view. Use X bar for mean. So here I can use count from, in fact, I can do it all the way down to 34. So it counted 10 values. Same thing with the sample mean. I can find the average from E5 to E34. And not sure if you know why I'm doing that, but it might be obvious here as I copy these over. So now I've got sample means for 5 samples of 10 and 5 samples of 30. And this worked out pretty well. So I'm going to save this because we're almost done. Here you can see where the sample size was 10, fairly small. We would have to assume that the population is normally distributed. Can we assume that it's normally distributed? Yes, because I told you up front that the values in column B were drawn off of a normal distribution with a mean of 75 and a standard deviation of 19. You can see with the first 5, 81,000, 87,000, 79, 82, 72, where we had quite a bit of variation. Here, we range from the low 70s. There's one right at 75. Here's one that's a little on the low side. Another one right at 75. And here's one that's 80,000. So in this particular, in the second set of 5 samples where the sample size was 30, we can see that there's much less variation, even just going from 10 to 30. And we wouldn't necessarily have to assume that the population distribution is normally distributed, even though it is. So if we were to draw more samples with larger sample size, we'd see the variation around these sample means to be closer and closer to 75,000. That still doesn't mean we can't get an outlier sample mean, if you will. It just reduces the chances quite a bit. The other key and final takeaway here is each time I draw a new random sample, I get a different sample mean. And for anyone who's taken a college or high school statistics course, one of the things that they haven't quite done but are starting to do is reinforce the fact that everybody thinks there's just one sample mean, but there are literally almost an infinite amount when you think about just drawing a sample of 10 or 30 out of a small population of 1,000. And so the issue there is be aware that you're just working with one sample out of a very, very large number of potential samples that could be drawn. And so the final reinforcement there is by drawing 5 different samples for each different sample size, as an example, I don't have a sample mean that is the same in any one of them. The closest two were the 75,000 here and the 75,000 here, which is a good thing. And perhaps I got a little bit lucky. So there's basic sampling from a population. We'll see you in the next video.